Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So those who are watching the particular session, just mark your attendance here by hitting the like button or giving hi to me. Hi Arush, good evening. So finally, here we are moving to our last part of the chapter, metals and non-metals. We will be discussing about the refining of metals, corrosion and so on. We will completing the chapter by today itself. We will practice some questions over here. So this is the content I am going to discuss here. First one, the refining of metals. Then what is the electrolytic refining? Then the introduction of the corrosion and the methods to prevent the corrosion. These are the topics we have to cover today. We are going to cover today. Ready? So in the last two class, we have discussed about the metallurgical process to purify the metals, right? First from the concentration of ores, then the extraction of metals from their ores. The last method or the last step in the metallurgical process is that the method is that the refining of metals. Even though if you are doing the concentration of ores or the extraction of metals, it will be containing some impurities. So we need to purify the metal again through the process of refining. Let us see what is the method of refining. So here is the first method, that is the electrolytic refine. What do you mean by electrolytic refine? Do you have any idea about that? As the same topic is repeating here. You have already studied in your first chapter, corrosion. The same topic we are going to discuss here also. Yes, with electricity, right? So electrolytic refining means we are refining or purifying the metals with the help of electricity. So what we are doing here, especially we are using copper, silver, gold, zinc and aluminium metals to purify by using this particular method, that is electrolytic refining. So as we already know, we have already seen about the electrolytic reduction, right? So in the case of electrolytic reduction, there will be two electrodes. What are they? What are the different electrodes which is used in the electrolytic reductions? Yes, anodes and cathode, right? So here also we need to take some two electrodes, that is, for example, the impure metal is made the anode, while the pure metal is taken as the cathode. For example, if you are taking the copper extraction here or copper refining or purification, we need to take the impure copper, right? Impure copper which is containing impurities as an anode, and the pure copper metal is made of the cathode. I hope you understand. Then for that we need an electrolytic solution. So I am taking an electrolyte solution which is a salt solution of metal which is to be refined. For example, if you are taking the copper extraction or the copper refining, I will be taking a solution of copper sulfate over here. Is that clear? This is a setup for the electrolytic refining of the metals. Yes, it is related to electrolysis. We are using the purification of metals here. That is why it is known as electrolytic refining with the use of electricity. Is that clear? So after electrolytic refining, what you are observing here, your pure metal will be deposited at the cathode and the impurities will be settled down at the anode as anode mud. Is that clear? Let us see the experimental setup here in detail. So this will be our experimental setup. I am doing the electrolytic refining of the copper. So what I am doing here, I am taking the impure copper as the anode, right? Anode is having the positive charge, right? Anode is having the positive charge in the case of electrolytic cell. So impure copper I am taken as an anode here. Then what will be our cathode here? It will be pure copper, right? Pure copper. So it will be connected to an external battery here. So this will be our acidified copper sulfate solution. We need to add some acid to the solution, electrolytic solution here. That is known as acidified copper sulfate solution. So when you are passing the electricity over it, what you are observing here, these electrons will move from here and the Cu2 plus will be the impure copper from the cathode. Impure copper from the anode will go to the copper sulfate solution, and the pure copper from the copper sulfate solution will be moving towards the cathode. Is that clear? Two electrodes are using here. One is anode and the other one is cathode, right? Anode and cathode. So now in the case of impure copper, we will be taken as an anode here, and cathode is taken as a pure copper, and external battery is supplying here to provide the electricity. So what you are observing here, the copper ions from the impure copper will be go towards the copper sulfate solution, and the pure copper from the copper sulfate solution will move to the cathode. So what you are observing here, our pure metal will be deposited over the cathode, right? So this will be our reaction given here. In the case of anode, always the reaction will be oxidation, right? Oxidation means loss of electrons, which means copper is equal to copper 2 plus 2 electrons. They are losing 2 electrons. Then what will be happening in the cathode? This Cu2 plus will accepting 2 electrons to form pure copper. So pure copper will be deposited over the cathode. Is that clear? Okay, this is the reason behind that. Soluble impurities will be remain in the solution. It will act as an anode mud here. It will act as an anode mud here. Clear? So this is about the electrolytic refining of the copper. Similarly, we can do the electrolytic refining for the aluminium, zinc and other metals also. So you need to focus on the diagram given here, which will be the cathode, which will be the anode, what will be the reaction happening in the anode and cathode. Then what is the anode mud? It is very important. Even though if you are doing some refining here, you will get some expensive metals like gold, silver in these impurities. So this anode mud is also very important. Clear? So finally we have discussed completely about the metallurgy. We have starting from here, right? We have seen what is the ores, minerals and everything. So how we can extract the metal from the ores. This will be our first step, that is the concentration of ore. Then what we are doing here, after concentrating ore, we are just extracting the metal depending upon the position of the metals in the reactivity series, right? Depending upon the position of metals in the reactivity series. So depending upon the position, we can say that highly reactive metal can be extracted by using the electrolysis we have seen yesterday. Then concentrated ore in the moderately reactive metal series, which means the metals present in the middle of the reactivity series can be concentrated or extracted by using the roasting and calcination method, right? Roasting and calcination method. You must have an idea about the difference between roasting and calcination. Then we are doing some reduction by using some reducing agent here. Most common example is carbon. We are using as a reducing agent over here. Then what about the last series? Less reactive metal or least reactive metal, which is belong to the bottom series of the reactivity series. They can be again purified by using the electrolytic method. Clear? This is the summary of metallurgical process we have discussed in the last 2 classes. So this is the same image taken from your NCERT textbook, so you can refer that. Okay. Now let us move to the main topic of the today's class, that is about the corrosion. What do you mean by corrosion? I hope you must have studied in the first chapter, right? So what do you mean by corrosion? Yes, it is an example of corrosion, right? Rusting of iron. So what is the exact definition for the corrosion? From rusting of iron, how we can explain it is a corrosion? Which is already highlighted here. The corrosion is the gradual destruction of the metals by chemical reactions with their environment, right? Chemical reactions with their environment. For example, if you are taking the example of rusting of iron, right? Iron will react with the oxygen and moisture in the air to form a compound, a complex compound that will act as a rust over there. Clear? Yes, destruction of metal or eating up of metal by water, oxygen or any of the content in the air. That will be the exact definition for the corrosion. Most common example is rusting of iron. So, this is the disadvantage of the corrosion here. This is a natural process primarily seen in metals like iron and can be lead to serious damage to structures, machinery and tools. So, this is the limitation of the disadvantage of the corrosion given here. Now, in the terms of chemistry, we can again define the corrosion as it is the chemically active metal. A chemically active metal when comes in contact with air, moisture or acid for a prolonged period of time. For a long period of time, it will be converted into its oxide. Hydroxide or other compound like oxidized form. So, this is the term, this process is known as corrosion in terms of chemistry. In general, we can say that it is the eating up or gradual destruction of the metals by chemical reactions with their environment. In chemistry terms, we can define that it is a metal can be reacted with the moisture or oxygen or acid from the compounds, right, from the air for a long period of time get converted to the oxide, hydroxide or other oxidized form to form a process known as corrosion. Is that clear? Just let me know, is that clear? How we can define the corrosion in two terms. One is about the general termination, another one is about the chemistry part. Now, these are the examples of corrosion here. So, what you are observing here in this image? Arush, you are asking about the rusting of iron, right? Fe2CO3 dot 10H2O, right? Sorry, Fe2CO3 dot 2H2O. That is the chemical formula of the rust. So, we need to focus on the equation properly there. Okay, what are you observing in this particular image? This is a statue. First you can see that this is a copper statue, right? So, after few years it is changing the color from this brown color, almost brown color to blue color, right? That is the process of corrosion here. Fe2O3 dot XH2O. It will be dot 2H2O depending upon the component. Yes. Okay. Rusting is the word specifically for the iron only. For in the case of copper, if you are asking about the corrosion, it will be another term known as tarnishing of copper. Clear, Arush? It's not about the rusting of copper, it is tarnishing of copper. Tarnishing of copper. So, what is the reaction happening here? The corrosion of copper can be visualized as a green scraped layer or green color over the metal surface because of the presence of copper hydroxide and the copper carbonate. So, this is the reason behind the tarnishing of copper carbonate dot copper hydroxide. Arush, are you able to see me? Is there any issue with the audio or video? Okay, fine. So, this is about the tarnishing of copper, right? Tarnishing of copper. So, what you are observing here, after a few years, the image of the statue get converted into a green surface, right? Green or blue surface because of the presence of copper carbonate, CuCO3 dot CuOH twice, copper hydroxide. Clear? Okay, same image, copper metal is converted to the tarnishing copper, CuCO3 dot CuOH twice. Yes, a lustrous copper metal undergoes corrosion by forming a bluish green scraps over it. Now what you are observing here in this image, in the middle we can see a silver pot, right, silver pot. The color is changing from silver to black, right, silver to black. Again the corrosion is happening here in the case of silver metal also. So what will be the reaction behind that? Here the silver metal will react with the hydrogen sulfide present in the air. Hydrogen sulfide present in the air. Right? So the silver converts to silver sulfide, that is the oxidized form of silver, which is black in color. Let us see the reaction here. So this will be our silver. This will react with the oxygen as well as H2S, hydrogen sulfide in the air, right? So it will be converting to the oxidized form of silver known as silver sulfide along with water. So this is the reason for the black color of the silver observing here. Is that clear? This will be the corrosion of silver metal. Yes, we need to learn the methods for the preventing corrosion. I will discuss in the last of this class. Here I need to focus about the examples for the corrosion here. So we have seen for the corrosion of copper, right? Rusting of iron. Then for silver it is again formation of Ag2S, right? Is that clear? Then the same example, that is the rusting of iron, right? Rusting of iron. We have already discussed. Again I am giving here an idea about that. It is the corrosion in iron is known as the rusting. So what is the chemical reaction observing here? The metal will react with oxygen as well as water content or the moisture content in the air to form the Fe2O3 dot XH2O. If you are taking 2H2O here, the final compound will be Fe2O3 dot 2H2O only. Clear? This is the hydrated form of ferric iron oxide, right? Iron oxide, which is containing a water content. That is why it is called hydrated iron oxide. Hydrated iron oxide is the rust, as we already know. This is the rusting of iron. Clear? Now let us see what are the different methods to prevent the corrosion. Even though corrosion is natural process, it will lead to the destruction of the metals, right? So we need to prevent the corrosion. So what will be the important methods to prevent the corrosion? The common methods we are using in our homes in order to prevent the rusting of iron. First one, it is painting, right? We are using the paint and corrosion inhibitors which protects the metal layer from the attack of air. So first method is using the paints. Then the next method, galvanization. It is a chemical method in which specifically used for the, yes, painting is one of the method. Then in the case of galvanization, it is the process of applying a protective zinc coating over the iron. It is the specific method to prevent the rusting of iron. Is there any process like vulcanization in the case of corrosion? Arush? Okay, I think it is about the galvanization. So what we are doing, we are applying a protective zinc coating over the iron so that it will does not react with the oxygen or iron from the oxygen or moisture from the air content in order to prevent the rusting. And the last method, it is the anodizing. So it is again an electrochemical method in which a metal is resistant to the corrosion by forming a protective oxide layer on its surface. Commonly it is used for in the case of aluminium. Clear? So these are the two chemical methods, galvanization and anodizing. Then using paints and inhibitors, corrosion inhibitors like oils or grease are also common method to prevent the corrosion. I hope you understand. Okay, I have no idea about the corrosion, about the magnesium. I don't know whether it is the same formula or not, MgCO3.MgOH twice. So now let us practice some questions based on the corrosion part. So here is our first question. What is the chemical name of rust formed during the corrosion of iron? Chemical name of the rust. 4 different options are given here. Ferrous oxide, ferric hydroxide, ferric oxide hydrated and ferrous sulfate. What will be the answer? Arush, we have already discussed only 2 terms here, no? One is galvanization and another one is anodizing. So it is easy for prevention of corrosion. So what will be our answer? Option C, right? Ferric oxide hydrated, Fe2O, yes, Fe2O3 dot XH2O. If you are taking 2 moles of water, it will be 2H2O. Clear? Here is our next question. The corrosion of aluminium typically results in the formation of which compound? Corrosion of aluminium. What will be our answer? Options are given here as aluminium oxide, iron oxide, copper oxide and silver oxide. I think you have already studied about the balancing of chemical reactions in the first chapter, right? So based on that, that will be the compound. If you are balancing the water as 2H2, it will be Fe2O3.2H2O. Or if it is 10H2, it will be like that. Yes, option A is the correct answer, right? Aluminium oxide. As we already know, only 4 options are given here. One is related to aluminium only. So obviously, option 1 will be our correct answer. Okay, now let us talk about the another topic from the chapter, that is alloy. What do you mean by alloy? What is an alloy? Any idea? Simply we can say that it is a mixture of metals, right? So alloy is a homogeneous mixture of 2 or more metals. 2 or more metals when you are mixing together. It will be a homogeneous mixture in which all the composition will be uniform throughout. Or a metal and a non-metal. If you are taking 2 or more metals also, if you are mixing with metal or non-metal also, we will get an alloy. So what you are observing here, this is our pure metal X, right? Pure metal X, which is in the smaller size, and this is our pure metal Y. If I am mixing these two pure metals, right, pure metals X and Y, I am getting an alloy that is a homogeneous mixture of these two pure metals. So this is the definition or the diagrammatic representation of an alloy. Is that clear? Yes, metals plus metal, metals plus non-metals, and non-metal plus non-metal. Okay. Do you have any example for that non-metal plus non-metal alloy? Let us see detail here. I have given some examples also here. So let us see the first example. Before that, we need to focus how we can prepare an alloy. There will be three methods, three steps to prepare the alloy. The first one, we need to melting the primary metal. For example, if you are taking the alloy of iron, you need to take the primary metal iron by melting. Then what you have to do, we are dissolving the other elements or other metals or non-metals in the definite proportions, right? Definite proportions. First step, we need to melt the primary metal. Second step, we need to add the other metals here, metals or non-metals here in the definite proportions. Last step, we need to cool them at to room temperature. Then cool to room temperature. This is the three steps to prepare the alloy of metals or non-metals. So this is the again diagrammatic representation. Here is a primary metal. These are melt mixing together, mix metal and metal elements together. So heat the metal mixture until all the ingredients are in the liquid form and mixed together. Then finally cool to the room temperature, we will get the alloy over here. Now let us see some examples of alloys here. The common example is gold. As we already know, the gold is 24 karat gold, right? Pure gold is 24 karat gold, but it is very soft. It cannot be used for making some ornaments in jewelries, right? Divyanshi, which compounds के product? Okay, our pure gold is 24 karat gold, right? So it cannot be used for making the ornaments. So that we are adding some other metals like copper or silver to make them hard. So that particular alloy of the gold is known as 22 karat gold. Yes, it will be 22 karat gold. Along with the gold, it will be containing some parts of copper or silver. Exactly 22 parts of pure gold is alloyed with 2 parts of copper or silver. So, if we are expecting 24 karat gold, in our all the ornaments, it will be only 22 karat gold. Clear? Divyanshi, I didn't get your question. Please explain the question once again. It's common for all the reactions or only for metals and non-metals? So that will be the alloy of gold over here. The next one, alloy of mercury. Alloy of mercury. So what you are observing here? In our teeth, if you have any damage in your teeth, we will be filling the cavities along with the mercury. That alloy of mercury is commonly known as amalgam. Clear? So when you are going to dental doctor, you will get a cavity over here which is containing mercury as a component here known as amalgam. Is that clear? This is an example of alloy of mercury. Harush, how it is possible? Did you get multiple balanced equations for a chemical reaction? If you are asking about the rusting of iron, we can commonly use this Fe2O3 dot XH2O. Now the next one is the alloy, that is known as brass and bronze. It is the alloy of copper. So primary metal will be copper. It will be containing zinc, then it is known as bronze. If it is containing tin as the another metal, it will be known as bronze. Sorry. Copper and tin will be bronze and copper and zinc will be brass. Don't get confused over here between brass and bronze. Both of them are the alloy of copper. One is mixed with the zinc in the case of brass, and in the case of bronze it will be mixed with the tin. These are the good conductors of electricity also. Clear? Yes, copper plus zinc will be brass, right? Copper plus zinc will be brass. Then bronze is also in the case of copper plus tin. The next one, it is solder. I hope you must see about this solder, right? These are the material which is used to welding the electric wires together. Electric wires together, we are using a material like this. This is known as a solder, which contain primary metal will be lead over here. Then lead is mixed with tin to form the corresponding alloy over here. Clear? The next case, it is German silver. It is the alloy of silver which is contain copper in the 25 to 30%, zinc in the 25 to 30% again, nickel in the 40 to 50% again. So these are mixing with the metals and metals, right? This is the German silver. Okay, this is the image representation here. The next one, again the alloy of iron. Alloy of iron. Generally, the pure state form of the iron will be very soft, so that we are just adding small amount of carbon here, about 0.05% to become hard and strong. So hard and strong, so that we are using the alloy of iron over here. Divyanshu, I will come back to you. I will just complete this topic here, alloy, then I will come back to you. Okay, when iron is mixed with nickel and chromium, right? Iron is mixed with nickel and chromium, we will get a stainless steel, right? Stainless steel. This is a common example of alloy of iron, right? Iron mixing with nickel and chromium. Thus, the iron is mixed with some other substance also. Its properties changes, right? Its properties changes. And the last case is a stainless steel, in which it is an alloy of iron that is resistant to the corrosion. So it contains at least 11% of chromium, 11% of chromium, and may contain elements such as carbon and other non-metals also. So this is the case of alloy of iron, that is the stainless steel. You can see the image over here. So this is the common examples of the alloys of different metals. Metals and non-metals, what is the primary metal, what is their name called, then their composition along with their uses. So you just go through the table given here just for a reference. Again, more examples are given here, you can go through it. No need to memorize all the alloys given here. You can just memorize these marked one only. 1, 2, 3, 4, 5, 6, 7. 7 alloys along with their composition and the uses, right? Arush. Divanshi, did you study any terms for that? How to find out the products for a particular reaction? Arush, generally take it as in the case of Fe2O3 dot XH2O. Don't confuse the 2H2 and 10H2O. You will be learn more about the corrosion part in the case of grade 12, I think, yes, grade 12. Okay, let us go to the activity time here. Divyanshi, I have no idea about how we can, there is any trick or tip to memorize the product, how to find out the product for a particular reaction. So, from the general formula, we can just identify whether it is forming oxide, carbonate or salt. So, here I don't know anything about that. So, here is the first question. An alloy is a, options are given here as pure metal, mixture of metals in any proportion, mixture of metals in a fixed proportion, and mixture of two non-metals. Divyanshi, for example, if you are taking H2 plus O2 gives, what will be our product? What will be our product? Water, right? This is from our basic knowledge. We can know that hydrogen and oxygen will combine to form water. I think in order to get an idea, you need to practice more reaction over here. I think in the first chapter you have studied more reactions, right? So try to understand the reactions. What will be the reactions? What will be the products here? So here from the basic knowledge, we know that hydrogen and oxygen combine to form water first. So just we need to do the balancing here, right? H2 plus O2 gives 2H2. Now it is balanced. There is no any trick to memorize how to find out the products. Okay, here our answer will be mixture of metals in a fixed proportions. So now you can understand the mixture of two non-metals cannot be an alloy, right? If you are going through the table also, you cannot see any examples for the non-metals. Non-metal mixturing, right? So here is our next question. The alloy used for dental filling is? The alloy which is used for dental filling. Options are given here: amalgam, brass, bronze and manganese. Yes, option A, right? Amalgam will be our correct answer. This is a mixture of alloy of mercury, right? Alloy of mercury which is used for filling the gaps in the teeth, right? So option A will be our correct answer. Here is the next question. Which one of the following elements is not present in stainless steel? Stainless steel. In order to answer these type of question, you must have idea about the alloy along with their composition of different metals, right? So stainless steel is the primary alloy of the iron, right? So obviously iron will be one of the component here. Then mixing iron with chromium and nickel will be the stainless steel, right? So what will be the element which is not present in the stainless steel? It is obviously option B, right? Tungsten will be our correct answer. Is that clear? Now the next question, which one of the following does not contain copper? You need to identify the alloy which does not contain copper. What will be the answer? Options are given here: solder, brass, bronze and German silver. Yes, solder is the correct answer here. Many of you make mistake that in the case of German silver, it will be silver, right? It will not contain copper, so we will put the answer as option D, but the correct answer is solder here. So if you go back here, so in the case of solder, right, it will be tin and lead only. Tin and lead only, but in the case of German silver, it contains copper, zinc and nickel as the components, right? Clear, Harush? Is that clear? Okay, fine. Here is our next question. Which of the following metals forms an amalgam with other metals? Direct question, we have already discussed. What will be the answer? Amalgam. Yes, mercury, right? No need of any more explanation here. So option B will be our correct answer, mercury. Dental fillings. Yes, that was our last question. That's all about from my side for today. So far we have discussed the complete chapter of metals and non-metals in details. I hope I have covered almost important topics from the chapter. So in that particular chapter, we need to focus on the metallurgy term in detail because it is very new topic for you. It will be containing in the grade 11 classes also. So metallurgy is very important over here, like the methods of concentration of ores, extraction of metals depending upon the position of metals in the reactivity series, and the refining of metals. For example, here we have given like the electrolytic refining, right? Yes. Then we have seen the corrosion, how to prevent the corrosion, alloys and so on. So just focus on the complete chapter once you completed the classes over here. Then what will be our next chapter? Which chapter you want to take from me? Do you need Mendy quiz for first 3 chapters or we will start the new chapter? So far we have completed 3 chapters, right? First one, chemical reactions and equation by Sushmita ma'am. Then acid, base and salts. Now metals and non-metals. Do you want Mendy quizzes for the 3 chapters or the new chapter I want to start? The next class. Periodic classification. Okay, fine. Let's see. I will try to cover those chapters also. So see you in the next class. The next Tuesday, the same timing, 5 to 6. I hope you guys enjoy the session. If you really like the session, hit the like button. Share our channel. Share this particular session to your friends and subscribe our channel Infinity Learn 9 and 10. If you want to get the session PDF here, you need to join our Telegram channel. Again, Infinity Learn 9 and 10 Telegram channel. You will get the session PDF after all the classes. Fine? So thank you so much all of you. See you in the next class. Till then, bye-bye.